Hey everyone, today I'll walk you through creating a Box-Behnken design like this one here using Python. I'm assuming that you already know what a Box-Behnken design is and when you use it compared to a central composite design. If you need a refresher, check the link in the video description. But now let's get started. Again, first things first, we need to install the latest version of the PyDOE package that we are going to use to create the Box-Behnken design, and the latest version is the PyDOE 3 version. And we do that by running this line of code here. If you already have the package installed, you can skip this step. Next, we'll import the necessary libraries. Besides the PyDOE 3, we'll also install pandas and NumPy to help us organize our data better later. And now we can already create our first Box-Behnken design, which is actually really easy. We already imported the bb design function where we need to specify the number of factors and how many center points we want. Important, you need at least 3 factors. It doesn't work with less because a Box-Behnken design doesn't make sense with less than 3 factors. Looking at the output here, you can see the design matrix. Each row represents one experimental run. And notice how with the Box-Behnken design, you do not test the corners of the design space where all factors would be at either +1 or -1. You always have one factor that is at 0. And then we have the center points at the end of the design matrix here. Depending on the variability you expect, you can adjust the number of center points included in your design by specifying the center parameter. The more variability, the more center points you should add. For example, if we set the center parameter to 5 and run the code, now we get 5 center points. Now let's transform this to something that we can actually use in the lab, because the raw matrix isn't really helpful when you want to go and execute the experiments. So after creating the design, I'm going to convert it into a pandas data frame where I can properly name the columns. And in my case, the factors were temperature, pressure, and concentration. And this here is already much better, but in the lab, we don't want to work with the coded values like -1, 0, +1. We need the actual temperatures, pressures, and concentrations that we're going to work with. And therefore, I created this handy function to translate the coded values into actual values. And it takes the data frame that we have created with the proper column names together with the factor ranges that we specify as a list of tuples, where we say that we want to test the temperature in between 100 and 180 degrees, pressure from 1 to 10 bar, and concentration from 0.01 to 0.1%. And when we run this code, we get our Box-Behnken design with real values as output that we now can also save to Excel and take to the lab. The full code is available through the description below. Give it a try and let me know how it worked for your experiments.